So I just wanted to frame what David's about to talk about. Some of the engineers in the room might know what IaC means, but for those of you that don't, those three letters stand for infrastructure as code. And this is a technique that allows us to specify the configuration of infrastructure, virtual machines, disk storage, databases, managed services that we want to use to deploy our software into. This is a very useful technique because it takes away a lot of the manual button pushing that we used to have to do to build an environment to run our software applications. Mojaloop has had an infrastructure as code feature for quite some time now, a number of years, and it has been consistently evolving over that time. David's going to talk to you about the current state of play with our IaC and the latest and greatest improvements that are coming along for our adopters to use. We have some upcoming focus with on-premise deployments that I'll be talking about specifically after David's slides. So please, when you're listening to David, bear in mind that what he's talking about is applicable to your upcoming POCs and Mojaloop deployments, test environments that you might be thinking about using. So without further ado, over to you, David. Thank you.
Thank you, James. So as James was mentioning, the IaC, infrastructure as code, is designed. It is a code-based way of describing the infrastructure that we're trying to deploy. And we are also matching that with GitOps as a deployment technique for the application stack. So the other thing that I wanted to mention about James' intro is he did mention that the IaC has been present within the Mojaloop GitHub repos and has been used. The first approach was with AWS. And the code that was built was very specific to AWS. So if we want to talk about the theme behind the latest modular version of the code is to provide a way for supporting multiple cloud providers as well as bare metal. And that obviously ties in with the bare metal work stream. So this presentation is talking about both how we've made the code modular, and it's a rewrite. It's not, we haven't made changes to the original code. We took some of the learnings from the first version that was going to be applied just for switches, for Mojaloop switches. Then we took another infrastructure as code approach that was designed for payment managers, that was designed to run on K3s and had a vision to run on bare metal. And we took those two learnings and the overall governing approach of making things modular to create 3 types of modules that will allow us to support different cloud providers, bare metal, as well as different applications. So we look here, there's three different types of modularity that I want to talk about. One is Kubernetes distributions. So K3s, micro K8s, and EKS is what we've tested with so far. But you can imagine that there's KubeSpray, there's AKS, there's multiple Kubernetes distributions that you could use. These are the 3 that we've tested in order to test out the modularity of that, of the actual Kubernetes distro. The second modularity is cloud vendors, and I'll say bare metal in the same category. So cloud vendors for infrastructure as well as bare metal. So we want to support those in a modular way that will allow a different vendor to just create the module for their cloud vendor, for their cloud infrastructure. And then that's decoupling the rest of the infrastructure from the infrastructure as code from what it's being deployed on. And then the last modularity is we should be able to run any application on this stack. And we've tested with Mojaloop and we tested with Payment Manager. So then where this gets you is you can run a switch on any infrastructure, on any Kubernetes distribution, and you can run Payment Manager on those same suite of choices. All right, so what I want to talk about on this slide, I know it's difficult to see many of the boxes, is that because this is going to set the stage for the rest of the discussion, on the left, we have a control plane. The control plane is running GitLab as the source of truth for the environments that we're going to spin up. It also has GitLab CI runner, which allows us to use pipelines within GitLab in order to build out the infrastructure that we want. It has support for a meshed WireGuard VPN that allows each of those environments to securely talk back to the control plane. And it also has a Vault that is running within the control plane for securely managing secrets that the environments need access to. On the right, we have the switch environment. This is what we're trying to provision. And so the idea is within the control plane, we're able to provision an environment on bare metal, another environment on AWS, another one on Azure, and the switch environment on the right side has the configuration it needs to run on those particular environments. But since it's done in a modular way, the control plane doesn't really care where it's being spun up, whether it's bare metal or otherwise. So speaking to the modules of IaC, the way that it's been split, I want to quickly talk about the three types of modules. One is the base K8s infra. This is cloud specific or bare metal specific. This is how you spin up your virtual machines or your bare metal. You can imagine that there could be a VMware module or etc. But this is how we actually deploy. Now you can deploy manually and then provide the configuration information in a YAML file to say, these are the IP addresses of my Bastion host, here are the IPs of my nodes. And from that point forward, it doesn't matter that it didn't actually spin the infrastructure up, but it will create the right configuration for the next module. So the first module is, how do I actually spin up my infra? And that will output an inventory file for the second module, which is Ansible. So for those who are not familiar with Ansible, Ansible is a way in which you can, it's another infrastructure as code language. And so we're using primarily Terraform and Ansible. So the Ansible module allows you to run playbooks on top of different hosts, and it doesn't matter whether those hosts are running in a bare metal situation or a cloud. They can run equally using the same configuration. Playbooks are designed in order to run different tasks, and the tasks have been designed with roles so that regardless of whether you're running a micro K8s cluster or K3s, those roles will be executed in the right way by the playbook. And the last one is GitOps deployment module. So I'm going to talk briefly about what GitOps is. GitOps is an inversion of control for how you decide what to deploy in your cluster. And whereas typically, and then in the older version of IaC, we would use the pipeline of GitLab to push changes using a kubeconfig into the cluster. So GitOps turns that on its head. And what you do is you define the source of truth of what you would like in your cluster. in a repository. And in this case, we have a repository in GitLab for each environment. And there is an Argo CD, in this case, controller that's running within the cluster that's polling that repo to find out what is the source of truth that it wants to deploy into itself. So the benefit of this is it's constantly monitoring to see if there's any drift in the environment, and it's pulling the latest and making sure that any changes are proactively pushed into the cluster. So that GitOps deployment model is independent of what cloud you're using or bare metal that you're using for your infrastructure. It is a description of the applications that you want to deploy, and it's standalone in terms of it's reusable across all the cloud providers in bare metal. So again, the base K8s, you would need to write one of these for a cloud provider if it already hasn't been written. It's Terraform based, and it creates the necessary infrastructure for Ansible to then deploy on top of. The second module, the Kubernetes cluster module. So this is Ansible based. The playbook is designed on a distribution basis. So Micro K8s has one, K3s has a different one, EKS has a different one. And so these playbooks make use of reusable roles in order to deploy into the cluster into the infrastructure. So step one, provision the K8s cluster. And again, here are the options that we've been talking about: Cube Spray, Micro K8s, K3s, the managed Kubernetes options. Step two, so now you have a cluster. Now we need to seed it with Argo and a couple of other elements. NetMaker is what I mentioned is the meshed WireGuard network. External secrets allows us to pull secrets from a vault or from GitLab into the cluster. And in particular, you can imagine that you have to securely be able to communicate from Argo to your GitLab repo, because you're not going to let this to be open to the internet, and you're not going to allow it to be publicly accessible or anonymously accessible. So we seed the right information for Argo to be able to communicate and get that state, the desired state of the cluster. And then we create a root application for Argo that points to that repo and then is polling for changes. So that is the setup for the Kubernetes cluster module that, again, is Ansible based. So at this point, you don't need kubeconfig or you generate a kubeconfig out of this module, but you don't need it within your CI/CD. CI/CD has no interaction with the environment from this point forward. All right, last module, GitOps module. It runs on any K8s cluster. It doesn't care whether it was built on EKS or it was built on bare metal. And excuse me, what it does is it's Terraform. Again, it creates the configuration files that each of these applications below need in order to function correctly. So the suite of applications which are foundational to the cluster are external DNS, certificate manager. Longhorn is what we're using for storage. However, this could be replaced. HashiCorp Vault config operator. We manage stateful resources. And when I say stateful resources, I mean databases. We manage these in a configuration-driven way that allows us to deploy them either in the cluster. So you could have your MySQL and your Kafka deployed in cluster, or if you change the configuration file for the stateful resources, you can point it to a managed service. So RDS in the case of AWS. And there is another module that I haven't pointed out here, which self-creates these managed services and then changes the configuration of the stateful resource to point to the managed service instead of the in-cluster. But this is handled transparently. Istio. So one thing you notice here, no WSO2. Well, thank you. Now we can tell who's been around for a long time. I've been trying to kill WSO2 for many years. So no WSO2, that means we're using Keycloak as an identity management provider and Istio for service mesh and ingress and egress gateways. So no WSO2 at all. And it required quite a bit of work in order to unwind a lot of the WSO2 dependencies that had grown into various components. But I can happily say that those have been all put to rest. And then the last one is why we're all here, Mojaloop. And this is an option. You can also deploy Payment Manager on top of the same infrastructure with no changes except a configuration file saying, I want to install Payment Manager and not Mojaloop. So that allows Payment Manager to be deployed on bare metal, on any of the Kubernetes clusters that we've mentioned, on any of the different cloud providers that would be supported, which I think is a great opportunity to be able to spin up payment managers in the ways that, in the scenarios that we all think it should be deployed in. So after this module runs, what you get is output into a GitLab repo for that environment. There's no secrets in there. This is all pure configuration. Secrets are generated into Vault, into HashiCorp Vault, and those secrets in HashiCorp Vault are automatically created as Kubernetes secrets within the cluster and referenced by those configuration files that have been generated. So the Argo CD operator that we talked about previously is then pulling that information and deploying it into the cluster. And that's what deploys your Mojaloop or your payment manager instance. All right, so what do we have? GitOps is managing the deployment for the base components for security, ingress control. I didn't mention the Grafana Loki stack that's also deployed to provide monitoring as well as log analytics. And then it's supporting the modularization, the ability to either deploy Mojaloop or Payment Manager, or if there was another application that you wanted to deploy and make use of all of these base components that are a part of it, it would be easy to write the deployment artifacts to do that as well. So security baseline, we have Connection Manager, Keycloak, and Istio, which are providing the IP whitelisting, mutual TLS, JWT validation, and JWS validation. And work in progress, obviously those should have numbers that go up. We want to use OriStack, which is something that we're using currently, and use OriStack in order to provide a consistent authorization component for both APIs and web applications. All right, just highlighting what we've done in this PI. We've added micro K8s as a second Kubernetes option. So that was in addition to K3s. We added EKS as a third K8s option. We got rid of WSO2 and added and Nginx and added Istio. We've brought in Keycloak, as I mentioned, for JWT issuing as well as identity provider, and tooting the WSO2, no WSO2 horn. Another thing that we added was the K6 instance. That's a automated optional component to be deployed into a switch environment. And this is a part of in anticipation of the performance workstream to be able to make use of this option to automate the running of performance tests against a cluster that's built with this infrastructure as code. Okay, payment manager deployments, we already mentioned, uses the same IaC. Now we're finalizing the bare metal deployment modules. So we have a bare metal setup where we've deployed using all three of the modules that I discussed. Right now, we are working on the load balancing component for the bare metal, but the GitOps functionality is working. So we're pretty close to finishing bare metal deployments. We built out, I believe I already mentioned the managed database services as a drop-in configuration replacement, and that's been tested with RDS, and we have managed Kafka waiting in the wings. We also have provided post-sync golden path test execution into Argo. So when Argo does a Mojaloop deployment, after it's finished, it automatically runs the golden path test using the TTK CLI, and that's integrated in with the TTK front end. And last but not least, Connection Manager. We've integrated Connection Manager to use Keycloak, and we've also, it's not on this slide, but have also integrated Payment Manager to authenticate it itself against the Keycloak of the switch as well. So what are the next steps? We are working with community members to build out the managed Kubernetes models for AKS and OCI. We need to finish end-to-end testing through Payment Manager. This is something that's imminent. The fully flesh out the K6 usage for the performance testing. As I think I mentioned already, the Kafka implementation on AWS, so we have a managed service option for that. And then we need to complete the testing of the bare metal module. And we are putting here a request for a contribution for security assessments. I don't think that it comes across very well. I had a couple of screenshots that I wanted to share to show a pipeline about how what you do to deploy an environment. It's basically one button for deploying. You can also deploy managed services as well. And outside of that, there's a destroy. So pretty simple interface. This is where you can get your kube configuration for administrators under the job artifacts. This is showing a successful run of a deployment. This is all within GitLab CI. And that really doesn't come out well. What I wanted to show is in one configuration file, you can set up multiple environments. The top one is a dev environment that is running, I think you can see on the third line, Cloud Platform AWS. The below one is dev one. The cloud platform is bare metal. So what you saw on the previous slide was one of the environments finishing its run and providing its kube config as an artifact to be downloaded. So you can run the same CI job for each of these environments. It's the same process, and you get the kube config out, and then you're able to, if you have administrative access, you're able to access those clusters. So would ask the community to participate if there's interest. We have a lot of work, as I was showing on the 2 slides ago. And these are the GitHub repos, the 2 main ones that are being used or actively developed. And here you have my contact details.